Hey guys, it's Chris at Highline Guitars. You're watching another one of my YouTube guitar building videos. If you're new to my channel, welcome. I hope that by the end of this video, I'll have earned the honor and privilege of your subscription. So in today's video, I'm going to be installing the electronics for my 6-string multi-scale fan fret guitar. Now, I've already installed the pickups. So what I'm actually going to be doing is installing the volume pot, the tone pot, the selector switch, and the jack. And then I'll be connecting the pickups to the selector switch. And once that's done, at the end of this video, the electronics will be done and I'll actually be able to strum the guitar and you'll be able to hear the sound coming out of the amplifier because the electronics will be finished. So let me bring you in closer and I'll show you what this is going to involve. So these are the components that I'm going to be installing in the guitar. Now I've already installed the pickups, and what I'm going to do now is install the controls that affect how the pickups work. And what I have here are 2 potentiometers, an output jack, a pickup selector switch, capacitor, and the hookup wire. Now, we'll start with the potentiometer. There's 2 of them. One of them is going to control volume, the other will control tone. Now there are a lot of different kinds of potentiometers that you can install. There are different brands, there are different styles of taper, and then there are different values. Now as far as the brands are concerned, the most common brands, the ones that people use the most on guitars, are CTS, Borns, and Alpha. These are Borns. Now I like Borns because the shaft turns very easily. Alphas are turning a little bit harder and they have sort of the same feel as a high-end stereo system, like an amplifier on a stereo where the knob has that slight resistance as you're turning it. And then CTS sort of slots in between the two. But I really like the Borns because it is so easy. So when you're playing guitar, you can roll the volume or the tone with just your pinky. It's very easy. And as far as the style of taper, there's basically 2 kinds of taper that you can get with a pot. One is logarithmic and the other is linear. With logarithmic, the tone or the volume, as you turn the knob, it doesn't seem to do a whole lot, and then all of a sudden it starts to change, and then towards the end it seems to do very little. So it feels like it's more in the middle, that it's doing most of the adjustment to either the volume or the tone. With linear, it gradually changes all the way through equally as you turn the knob in either direction by increasing the volume or changing the tone or going in the other direction. I prefer to use linear. I just like the way they sound. But there's no hard and fast rule here. You can try both. Pots are fairly inexpensive. So when you're wiring up your guitar and you're trying to decide which one to use, you could pick up a logarithmic and a linear version of each one and try them out and see which one changes the signal that is appealing to your ears. Everybody's a little bit different. So I prefer the linear. So that's what I'm going to be using on this guitar. Now when I mention values, what I'm talking about is the amount of resistance across the resistive element that's inside the pot. See, when you're turning the knob, there's a sweeper inside there, and that sweeper moves across a resistive element, and that's what changes the resistance and affects the volume and the tone. Now, typically this resistance is measured in ohms, and for guitars, the most common values are 500,000 and 250,000, but we typically say 500K pot or 250K pot. But you're not limited to those values. There are a wide range of values above and below those numbers that you can actually try out. And this gives you the ability to really dial in the performance of the guitar as far as how it increases and decreases the volume and how it affects the tone when you adjust the tone knob. So really what you end up having to do is do some research to find out what type of pots are typically used in the style of guitar you're building, and then maybe get a couple of pots in values that are around that range. For example, these are 500K pots. If you want to experiment, you could get a 250K, you could get a 300K, you could jump above it and get like a 1 meg pot. Pots are fairly cheap, so you can purchase those different values, try them out in the guitar, and see which one you like the most, which one gives you the performance and the results that you feel are most appealing. For my guitar, I'm using 500K pots, and I like using 500K when I'm using humbucker pickups. I just like the way it sounds. But you could also try, like I said, the 250, 300, 1 meg, whatever, and dial in that tone. Now, connected to the tone pot, to make it function correctly on the guitar, we need a capacitor. Now, I have two capacitors here. What's interesting is they are both the same value. However, obviously one is massive. And the reason why I'm showing these two is because it's easy to make a mistake and purchase what you think is the correct value capacitor when in fact it's not the right size, and you end up with a capacitor. Something like this would be designed for an amplifier, not a guitar. This is the type of capacitor, or the size at least, that we need for an electric guitar. Now, since I'm not going to be actually using this giant capacitor, just to make things less complicated, I'm going to move it out of the way. Now, as far as selecting a capacitor, there are a variety of different styles of capacitors. You have your ceramic capacitors, paper and oil, and then this particular type, which is a polypropylene capacitor. As an interesting side note, you can make a capacitor out of a potato. But obviously that's not going to work in a guitar. This particular capacitor is a Sprague orange drop capacitor, and like I said, it's a polypropylene, and this is what I like to use. All the other ones, they have their own unique effect on tone. So what it comes down to, again, like the pots, is if you're not sure and want to try a bunch of different ones, you can purchase different values as well as different styles, the ceramic, the paper and oil, polypropylene, whatever. And then you can try those out in your guitar and see which ones you like the best. Another important factor to consider is the value of the capacitor. And the value is rated according to the measurement in microfarads. And the most common that are used in electric guitars are 0.015 microfarads, 0.022 microfarads, and like this one, 0.047 microfarads. Now, as that number gets higher, the tone tends to get darker or warmer. So keep that in mind. And you're not limited to those three values. You can choose any value anywhere near that and try those out and see what they do in your guitar. You know, I've had a lot of guys over the years, when they've asked me to build them guitars, they'll say, just skip the tone pot, because in every guitar I've ever owned, the tone pot doesn't do anything. Well, that's only because they probably have guitars that don't have the right value capacitor. And by simply changing the value of the capacitor, all of a sudden the tone pot becomes this magical tool that can adjust the tone of your guitar just by turning the knob, and it can do so dramatically. So as long as you pick a value that you feel sounds the best, that's what's going to give you the performance that you want from your tone pot. And that's really what's critical. Otherwise, the tone pot may not sound like it's actually doing anything. The next component is going to be the pickup selector switch. And I'm just using a simple 3-way toggle switch. This is a Switchcraft. I only use Switchcraft. They are the highest quality, and the switch is something that gets so much abuse. You need a good high quality switch. A lot of those import ones will fail after constant use. And at some point you'll find that you can't switch between pickups. So I use the Switchcraft, and it's a good heavy duty switch. Now typically when you purchase these, you have to purchase the switch and then the tip separately, and you can get different color tips. This one is an amber tip. They also have white, black, gold, silver. So just be aware of that. And then last but not least, I have the jack. Now in this case, because of the design of this guitar, I'm using a barrel jack. These are commonly found on acoustic guitars, but they work the same as just a regular jack. Usually if I'm not using a barrel jack, I like to use the Switchcraft jacks, because like the Switch, they get a lot of abuse. But for this one, I'm using this barrel jack, which will install into the lower bout, the rear lower bout of the guitar. And there's really not much else. I mean, there are mono jacks and stereo jacks. Now typically with a passive pickup electric guitar, we use a mono jack. And then if you're doing active pickups, like your EMGs, you would use a stereo jack for those. So the last item is the wire that's going to run between all the different components. I use nothing but shielded wiring in my guitars. And what shielded wiring means is the wire has a central core, which is the conductive part, and then that's wrapped in a sheath of plastic or PVC. That in turn is wrapped in this very fine wire, which is a shield that wraps around this inner core portion, and it runs the entire length. And what this does when grounded is it shields this inner wire, the signal wire, from electric noise or interference, EMF. And then the whole thing is wrapped in this outer coating of the outer jacket. So I use this type of wiring to connect all the components together. And then my pickups use a very similar shielded wiring, except it has two conductors on the inside. And the reason I use this kind of wiring instead of your ordinary traditional copper stranded wire is because in electric guitar, the wire can serve as an antenna for electrical interference. By shielding it and then grounding the shield, you eliminate that problem. So all of my components, my pots, my switch, my jack, the wiring, it's all shielded and it's all grounded. That eliminates the need for putting in any sort of copper shielding or shielding paint or anything like that, because now all the electronics are about as well shielded from outside noise, electrical interference, as you could ever get it. And it's just a simple, clean way to do it rather than having to use copper foil. So that's what I'm going to use to connect all the components together. Okay, so we're here at the workbench and I'm ready to start soldering all the components together. And this isn't really going to be a detailed tutorial on how to solder, although you will see how I do it. But what I have here is, this is just a block of wood that I drilled some holes into, and I use that to hold the components as I'm soldering. And I'm doing this outside of the guitar because I want to try and do as much soldering as I can outside of the guitar before I install the components. That way I won't accidentally drop a soldering iron or wire cutters or whatever onto the guitar as I'm doing the work. So I'll do most of the soldering here, and all that will be left to solder once I've installed these into the guitar is to solder the jack, because that has to be done afterwards, and then to hook the pickups up. Now I also have a wiring diagram, and this is optional. I use these if if I'm doing a wiring scenario that I'm not familiar with. But if you've never done this before, you can go to the Seymour Duncan website and you can specify the type of wiring that you're going to do, and it'll present a diagram that you can follow to do all your wiring. Another option would be to purchase The Complete Guitar Wiring by Jerry Hayes. Now, I'll put links to all this stuff in the description down below so you can check these out for yourself. But this book, aside from telling you absolutely everything you'll ever want to know about guitar electronics, it also includes a wide variety of wiring scenarios that you can use to guide you as you do the work. So it's an incredible reference, well worth the money. So what we're going to do now is I'm going to begin to solder the electronics. And the first thing I have to do is switch on my soldering iron, and I'm using a Silodi SSA51. I'm not sure if these are still available. I'll put a link to either this one or one that's similar down in the description below so you can check it out. I really like this one because I can adjust the temperature of the soldering iron for different soldering situations. Now, the solder that I'm going to be using is, this is Kester 0.031 inch in diameter or 0.8 millimeter diameter. And this is a rosin core leaded solder. I do not use lead-free solder when I'm wiring up the electronics because it tends to fail. So I save the lead-free from when I'm doing plumbing work, but for electronics I use leaded solder. And because of that, I have a fan. You can't see it on screen, but I have a fan which is pulling the air away from where I'm working. Because obviously lead solder is not a healthy, the fumes from it are not healthy to breathe. But the first thing I want to do is I want to tin all of my connection points on each of the components. So I'll do that, and this just makes soldering easier. I've already tinned the switch, but I'm going to add a little bit more solder to it. And then what I also like to do is I'm going to put a blob of solder on the back of the pot, because that will be where I connect ground wires from the pickups as well as from the jack. All right, now I can start soldering the wiring and the capacitor. Okay, so what I'm going to do is I'm going to solder the capacitor. And with a capacitor, it doesn't matter which side is soldered to where, but one side will be soldered to the one of the lugs on the, actually the middle lug on the front of the pot, and then the other one will be soldered to the back, to the ground, but it doesn't matter which side. Now I'm going to solder a wire from the volume pot to the selector switch. So I have to strip it first. And then I'm going to use this little helper to hold the wire while I tin. I need to tin both the core as well as the shielded wiring. Now I'm going to solder the end from the back side, and that just makes it easier for me to solder this shielding to the back of the pot without it touching anything else. Then I'll figure out how much wire I need to get to the selector switch. So I'll cut that off. And then this wire will be connected to the lugs on the selector switch, which are always in contact regardless of the position of the switch. First I need to tin. Now by soldering the shielding to the back of this pot, I don't need to solder this end, so I can just clip it off. And now what I need to do is connect the volume pot to the tone pot. Now I need to connect the wire that's going to be soldered to the hot lug on the jack, and that'll actually be soldered in later, but I need to solder in the wire right now to the pot. And this is obviously soldered to the volume pot. And again, I have to solder the shielding to the back of the pot to ground it. Now what I have to do is I have to solder a wire from the back of the volume pot to the ground lug on the selector switch. Then I have to solder another wire from the back of the tone pot to the ground lug. That way, when I solder the ground wire from the jack to the back of, it's probably going to be the tone pot because that'll be closest to the jack. All of these components will be grounded. All right, the last thing I have to do is solder the ground wire that will be soldered to the ground lug on the jack. One thing I almost forgot to mention, in order for the volume pot to work correctly, this unused outer lug needs to be connected to ground. So the easiest way to do that is to simply bend the lug and then solder it to the outer casing. Now I can start to install the electronics into the control cavity. Now, one thing that's important to keep in mind is the orientation of the selector, and it's personal preference, but I like to have it so that when I'm switching the pickups, the switch is going from front to back. So when I'm in this position with selector switch towards the front of the guitar, the neck pickup is selected. And then at the back, the bridge pickup is selected. And then of course in the center, it's both. So that's how I have it arranged. And then when I hook up the pickups, I have to know which lug I need to solder the bridge pickup to and which one to solder the neck pickup to. So when I flip the switch to select the neck pickup, what it's doing is it's pushing out this side from its contact point and disconnecting it. So if it's forward and this side's disconnected, then I know that this lug is for the bridge pickup. And then when I flip to select the bridge pickup, it's pushing this lug out. So I know that this lug is actually for the neck pickup. I hope that makes sense. Now I have three, well, actually I've got 1, 2, 3, 4, 5, 6, 7 wires that I need to connect. I have the bridge ground, then I have the hot and the ground and the shield wire for the bridge pickup, and then the same thing, the hot ground and shielding ground for the neck pickup. So what I'll do is I'll put the signal wire, which is the white wire, they'll be soldered to the appropriate lugs on the selector switch. Then the ground wire and the shielding ground will be soldered to the back of the control or of the potentiometers, since those are grounded. And it's always a good idea to snip away any excess wire that might be sticking out from your solder joints. Okay guys, the wiring is finished. Everything works as expected except for one thing. And I don't know if you noticed when I was strumming the guitar after plugging it into the amplifier a few seconds ago. You might have noticed that when the two pickups were selected together, they're out of phase. And I'm gonna have to play around with this for a while and decide whether I want to change that. It probably would just mean doing some rewiring of the lead hookup wires to the pickups, or I may just leave it. I haven't decided. We'll see. But for now, everything is working as expected. The volume works, the tone works, selector switch works, jack works, everything is working. So I think the next step is going to be to continue with the assembly, as far as I'm probably going to take a look at finishing up the frets, because at this stage all I have done was a cursory level. And what I need to do now is to revisit that, make sure that all the frets are level, that there's no string buzz. Then I can recrown and polish the frets. So I'm probably going to be doing that in the next episode. So I hope you've enjoyed this episode. If you have any comments or questions, post them down below. And if you enjoyed it, as always, please click that thumbs up button. I say that every single time, but you got to understand how much that helps a channel like mine. And if you want to take your support to the next level, you can visit eguitarplans.com or my Highland Guitars merch store, and there you can purchase plans for guitars, for the tools that we use to build guitars, and you can get a cool t-shirt, coffee mug, hoodie, that kind of stuff. But know that whatever you spend is going to help support this channel so that I can keep building these guitars, making the videos, and then sharing them with all of you. So it really does help. And if you want to keep your support simple, you can click the thanks button and leave a tip in whatever amount you think is fair. And of course, if you have a question that you really, really want answered, you could include a tip and a question at the same time, and I will absolutely answer it. So as always, until the next episode, take care, stay safe, and I hope you'll be back for more guitar building videos.